Like everything's constantly moving, planets, stars, galaxies, all zooming around at these, well, incredible speeds.
Uh-huh.
And then you think about EMCA, that famous equation. It says even like a tiny bit of stuff that's just sitting there has this huge amount of energy packed inside.
Yeah, absolutely.
So I guess what we're diving into today is, how do those two things connect? The energy of just being still and all this cosmic motion.
That's a really great question, and it gets right to the heart of some pretty deep physics. We've got some interesting material here looking at exactly that mass energy motion.
Okay.
Our mission, really, is to unpack how EMCA fits into this, well, very dynamic universe. And yeah, it starts with that idea of rest energy.
Rest energy.
Yeah.
Right. So EMC, right. That's saying something has energy just because it has mass, even if it looks perfectly still to us.
Yeah.
Like energy just for existing.
Exactly that. It's the energy something possesses purely due to its mass. Think of it as energy locked inside the matter itself, separate from any movement or, position relative to other things.
And the scale of this energy is just wild. The sources mention converting just 1 kilogram of anything totally into energy would yield something like 9 times 10 to the 16 joules. I mean, you can't even really picture that number, can you?
No, it's almost beyond comprehension. It's similar to the energy released in, massive nuclear events. And the key thing here, the really crucial part, is that this MC energy exists whether that kilogram is, say, sitting on your table or floating completely still out in deep space.
Right. So it doesn't matter if it's on Earth whizzing around the sun or in some imaginary spaceship that's perfectly stationary relative to,
Yeah.
well, something. It still has that energy, the energy of just being.
Precisely. That's the foundation. Now, let's bring motion into it. When an object starts moving, it picks up another kind of energy, kinetic energy.
Kinetic energy, the energy of motion. Yeah, I think most of us remember the simple version, half mv squared for everyday speeds.
Right.
But when we talk cosmic speeds, things get, well, relativistic, Einstein's territory.
Definitely. Once you get close to the speed of light, that classical formula, it just doesn't cut it anymore. You need special relativity.
Yes.
And the relativistic kinetic energy, the formula looks a bit different. It's Ke equals gamma minus 1 times MCO.
Gamma. Okay, the Lorentz factor, that's the one over the square root of 1 minus v squared over c squared thing.
That's the one.
And that factor, it starts getting really big as the velocity v gets closer and closer to c, the speed of light.
Exactly right. Gamma tells us how measurements like time and space change for fast-moving objects.
Right.
As v gets closer to c, that vc part gets close to 1.
Uh-huh.
So 1 minus, that gets really small, the denominator gets tiny, and gamma shoots up towards infinity.
Which means infinite energy to actually reach light speed.
That's the implication. For anything with mass, accelerating it to the speed of light would take an infinite amount of energy. Kind of puts a limit on things.
Yeah, just a bit. Okay, so we've got rest energy, MCFG, and we've got this relativistic kinetic energy, the 1 MCFG, for things moving super fast. How do they add up? What's the total energy?
Well, it works out quite elegantly, actually. In relativity, the total energy is just the sum of the rest energy and the relativistic kinetic energy. And when you combine them, the total energy, A total, is simply gamma times MCFC.
E total is GAMCO. Okay, that makes sense. Because if something's not moving, V is 0.
Then gamma is just 1.
Gamma is 1, and E total is just MCFC. You get back to the rest energy.
Exactly. So at rest, total energy is rest energy. But as it moves, V increases, gamma gets bigger than 1, and the total energy goes up. That extra bit, the energy above MCFC, that's the kinetic energy.
Okay, got it. Now, thinking back to the original question about the, incredible speeds in the universe. And they really are incredible from our perspective. Earth's going around the sun at like 30 kilometers a second.
Yeah.
The whole solar system is doing maybe 220 kilometers a second around the galaxy. And the Milky Way itself, moving relative to the cosmic microwave background radiation, maybe 600 kilometers per second. It seems like a lot.
They are very high speeds in human terms, absolutely. But the key is comparing them to the speed of light. Light travels at about 300,000 kilometers per second.
Right.
So even that 600 kilometers per second, as the sources note, is only about 0.2% of light speed. 0.0002 c.
So really tiny, fractionally speaking, which means the gamma factor, even for these huge cosmic speeds, it's barely bigger than 1, isn't it? The source says for 600 kilometers, gamma's like 1.000002.
That's right. It's incredibly close to 1. So yes, these cosmic motions do add kinetic energy, but that kinetic energy is absolutely minuscule compared to the object's rest energy, the M psi part.
So, okay, the main takeaway here is that the EMC card energy, the huge chunk of rest energy, It isn't because of the object flying through space.
Yeah.
It's just there,
Well, this is
intrinsic.
a very important distinction.
The motion just adds a little extra kinetic energy depending on like what you're measuring its speed relative to.
Exactly. Rest energy, MCR, is defined in the object's own rest frame. Imagine you're floating right alongside it, perfectly still relative to it. In that frame, its energy is MCR.
Mm-hmm.
The kinetic energy we measure due to its orbit around the sun or its motion with the galaxy, that depends on our frame of reference relative to the sun or relative to the galactic center or the cosmic microwave background.
Right. Which I think leads to that really interesting thought. Could the rest energy itself, the MEMC bit, actually be some kind of kinetic energy from a really fundamental motion we don't normally see? Like, is everything secretly moving at some primordial relativistic speed that gives it its mass energy?
That's a really natural question to ask, a very intuitive idea, and physicists have definitely thought about it. But a core principle of special relativity is that there's no absolute preferred rest frame, meaning the laws of physics work the same for any observer moving at a constant velocity. There isn't one special frame of reference that's truly at rest in the universe. So we can't really point to some universal background speed that everything is moving through to generate its MCFO.
Okay, so there isn't some cosmic grid or ether that everything's whizzing through, and that's what gives rise to rest energy.
Not in that sense, no. The modern view is a bit different. For fundamental particles like electrons, quarks, their mass actually comes from interacting with something called the Higgs field.
The Higgs field, right.
This interaction gives them inertia, which is essentially mass, and the MCO rest energy is then a direct consequence of having that mass.
Okay, so that's for the tiny fundamental bits.
Yeah.
What about bigger things, like protons and neutrons that make up atoms?
Well, for composite particles like those, it's even more interesting. A huge chunk of their mass and therefore their MC-on energy actually comes from the kinetic energy of the quarks and gluons buzzing around inside them, plus the energy stored in the strong force fields binding them together. It all happens within the rules of MC-ionosphere.
So the energy inside the particle contributes to its overall rest mass.
Exactly. It's like the internal motion and binding energy themselves have mass energy according to EMCRs, and that adds up to the particle's total rest mass.
Wow, okay. The source had a nice analogy, a spinning top.
Yes, that's a helpful picture.
The top has mass and therefore rest energy just sitting there. If you spin it, that's like adding internal rotational kinetic energy.
Analogous to the energy inside the proton.
And if you slide the whole spinning top across the floor, that's like the bulk kinetic energy from moving through space.
Precisely.
But the fundamental MCR was there before you spun it or slid it. The sliding didn't cause the MCR.
That's the idea. The MC psi is tied to the very existence and internal structure of the object, not primarily its overall velocity through the cosmos.
Okay, so let's try and wrap this up. AMC Hasiat is fundamentally about rest energy. It's the energy locked in mass itself, and it doesn't really care how fast that mass is moving relative to the galaxy or whatever.
Correct. It's intrinsic.
When things do move, they gain kinetic energy, and the total energy becomes gamma times MCR. But that original MPR wasn't caused by the motion.
You've got it. Mass itself, whether it comes from the Higgs field or from those internal energies and bindings, embodies that rest energy.
It's fascinating. So the universe is full of motion, incredible speeds everywhere, but the staggering energy inside matter isn't really a product of that motion. It's just a property of matter. It does make you wonder, though. Well, you have this constant motion everywhere, and you have this inherent energy everywhere. They seem separate based on what we've discussed, but are they completely separate? Could there be some deeper link between the energy of being and the energy of moving that we just, haven't figured out yet?
That is a fantastic question to ponder. It touches on the frontiers of physics, really. We're always looking for deeper connections, and the fact that you have this immense energy packed into seemingly quiet matter, all while it's participating in these grand cosmic dances, well, it certainly feels like there could be more to the story, doesn't it? More layers to uncover about energy, matter, space, and time.